The Costa Concordia was one of the largest and most luxurious cruise ships sailing the Mediterranean, stretching almost 300 meters in length and carrying more than 4,000 people when fully occupied. She represented the modern cruise industry's promise of comfort, entertainment, and effortless travel. Guests boarded expecting elegant restaurants, theaters, swimming pools, and unforgettable sunsets. Few could imagine that this voyage would become one of the most infamous maritime disasters of the 21st century. On the evening of the 13th of January, 2012, the ship departed Civitavecchia, the main port serving Rome, bound for Savona in northern Italy. The weather was calm, visibility was good, and the sea presented few challenges. Passengers settled into their evening routines. Families gathered for dinner, performers prepared for evening shows, and crew members carried out what seemed like another ordinary voyage across familiar waters. Yet the route ahead contained a dangerous decision. Rather than remaining well offshore, the bridge planned a close coastal passage near the island of Giglio. Similar maneuvers, sometimes referred to as a salute, had been performed by cruise ships to provide spectacular views for passengers and to acknowledge communities ashore. While visually impressive, such deviations significantly reduced the margin for navigational error. As Costa Concordia approached Giglio, the ship continued towards the rocky coastline at a speed of around 16 knots. Navigation systems accurately displayed the surrounding hazards, but the vessel was now traveling through waters where precise positioning was essential. Every minute brought thousands of tons of steel closer to submerged reefs hidden just beneath the surface. On board, almost nobody sensed that anything was wrong. Music echoed through lounges, glasses clinked in restaurants, and children played in brightly lit public areas. Crew members continued serving meals and drinks while guests admired the coastline illuminated against the evening sky. It was a picture of confidence and routine, masking the growing danger on the bridge. Then, at approximately 9:45 p.m., the illusion shattered. The port side of the ship struck an underwater rock with tremendous force. Metal screamed as the reef tore a massive gash through the hull. Compartments that had been dry only moments before filled rapidly with seawater. Electrical systems began to fail, propulsion was compromised, and the vessel immediately started losing stability. Passengers first noticed an enormous jolt, followed by violent vibrations that rippled throughout the ship. Lights flickered, furniture shifted, and confusion spread through corridors and dining rooms. Many assumed it was a temporary mechanical fault, but below the waterline the damage was already catastrophic. Within minutes, one of the world's most advanced cruise ships had begun the irreversible journey that would end with her lying helplessly on the rocks off Giglio, marking the beginning of a disaster that would claim lives, transform maritime safety, and trigger one of the most complex salvage operations ever attempted. Water poured through the torn hull with astonishing speed. Several watertight compartments flooded almost immediately, overwhelming systems that had been designed to keep the ship afloat after limited damage. As seawater spread through the lower decks, generators failed one by one. The ship lost electrical power, propulsion, and steering, leaving the bridge with rapidly diminishing control over the vessel. Although the seriousness of the situation was becoming clear on the bridge, many passengers initially received reassuring announcements suggesting there was only an electrical problem. Those few extra minutes proved critical. Rather than preparing immediately for evacuation, many people remained in restaurants, theaters, and cabins, believing the interruption was temporary. Meanwhile, the ship developed an increasingly noticeable list as thousands of tons of water accumulated inside the hull. Captain Francesco Schettino eventually maneuvered the powerless vessel towards the shoreline of Giglio, where Costa Concordia came to rest on a rocky underwater ledge. The decision prevented the ship from drifting into much deeper water, where a successful evacuation would have been far less likely. Even so, the steep angle of the list made movement through the ship increasingly difficult, turning staircases into climbing walls and passageways into dangerous obstacles. When the order to abandon ship was finally given, passengers and crew hurried towards the lifeboat stations. Some boats could no longer be launched because the severe list left them suspended high above the sea or trapped against the ship's side. Crew members struggled to organize frightened crowds in multiple languages while darkness, failing communications, and the growing angle of the vessel added to the confusion. On shore, the residents of Giglio immediately recognized the scale of the emergency. Local fishermen, harbor workers, emergency responders, and volunteers launched their own boats and headed towards the stricken liner. Throughout the night, they ferried survivors to safety, opened public buildings, hotels, and homes, and provided warm clothing, food, and medical assistance to people who had escaped with little more than the clothes they were wearing. Search teams continued working through the damaged ship long after the last passengers had been evacuated. Divers and specialist rescue crews entered flooded compartments and darkened corridors in the hope of finding anyone still alive. In the end, 32 people lost their lives in the disaster, while thousands of others survived an ordeal that would remain with them for the rest of their lives. As dawn broke over Giglio, the full extent of the catastrophe became impossible to ignore. Costa Concordia lay on her starboard side, dominating the coastline like a fallen city of steel. Around the world, television audiences watched images that seemed almost unbelievable. Questions quickly emerged about the decisions made on the bridge, the delay in ordering evacuation, and how one of the world's most sophisticated cruise ships had come to grief within sight of land. Those questions would shape years of investigations, legal proceedings, and sweeping changes to maritime safety. With the evacuation complete, Costa Concordia remained stranded on a narrow rocky shelf just meters from the shoreline of Giglio. It was an extraordinary and unsettling sight. A vessel that had once symbolized luxury and leisure now rested helplessly on her starboard side, her towering decks looming over the island. Had the ship slipped from the ledge into the deeper waters only a short distance away, recovery would have become vastly more difficult, and the loss of life could have been far greater. Attention quickly shifted from rescue to stabilization. Engineers feared that the wreck could slide into deeper water, carrying thousands of tons of fuel, machinery, and debris with it. Such a movement would have complicated any future salvage operation and posed a major environmental threat to the protected marine ecosystem surrounding Giglio. The immediate priority was to secure the vessel before storms or structural failure made the situation even worse. Specialist teams boarded the damaged ship to assess its condition. Every inspection presented new challenges. Many compartments were flooded, electrical systems had failed, and the ship's internal structure had been distorted by the grounding. Engineers carefully monitored movement within the hull, searching for signs that the wreck was shifting under its own enormous weight. Even a small change in position could have had serious consequences. At the same time, investigators began examining what had happened on the bridge. Voyage data recorders, radar information, electronic charts, and bridge communications were collected to reconstruct the ship's final minutes. The investigation focused not only on the navigational decisions that brought the vessel dangerously close to shore, but also on the delayed evacuation and the effectiveness of emergency procedures once the collision had occurred. Around the wreck, floating barriers were deployed to contain any leaking fuel or contaminants. Divers inspected damaged sections of the hull, while support vessels established exclusion zones to protect both the operation and the fragile marine environment. Removing the hundreds of tons of fuel still trapped inside the ship became an urgent task. requiring careful planning to avoid further damage to the already weakened structure. As weeks turned into months, it became clear that conventional salvage methods would not be enough. Costa Concordia was simply too large, too badly damaged, and resting in too precarious a position. Breaking her apart where she lay would have created unacceptable environmental risks, while lifting her directly from the seabed was beyond the capability of any existing crane. Engineers would have to develop a solution unlike anything previously attempted. The challenge attracted experts from around the world. Naval architects, structural engineers, marine salvage specialists, environmental scientists, and heavy-lift contractors combined their knowledge to design a recovery plan on an unprecedented scale. Their objective was remarkably ambitious: stabilize the wreck, rotate the entire ship upright, refloat it, and tow it away intact. It would become one of the largest and most technically demanding maritime salvage operations ever undertaken. By the middle of 2012, the emergency response had evolved into a global engineering project. Salvaging Costa Concordia would require techniques that had never before been attempted on a passenger ship of this size. The objective was clear: recover the vessel intact while protecting the island's coastline and marine environment. The challenge lay in turning that ambition into reality. An international consortium of salvage companies, naval architects, and heavy engineering specialists developed a plan centered on a single, daring operation known as parbuckling. Rather than lifting the ship vertically, engineers would rotate the entire wreck upright using an intricate network of cables, hydraulic strand jacks, and specially constructed underwater platforms. Every calculation had to account for the ship's immense weight, weakened structure, and unstable resting position. Before the rotation could begin, the seabed itself had to be transformed. Divers and construction crews installed massive steel support platforms beneath the section of hull that would eventually bear the ship's weight. The work was carried out underwater with millimeter precision, often in difficult sea conditions. Each platform had to align perfectly to prevent the hull from collapsing during the rotation. At the same time, crews stabilized the wreck using heavy anchor cables fixed to the surrounding seabed. These restraints reduced the risk of the ship shifting unexpectedly during storms or while construction continued. Engineers continuously monitored movement with laser surveying equipment and electronic sensors, watching for even the smallest changes that might signal structural failure. Another priority was removing pollutants from the damaged vessel. Hundreds of tons of heavy fuel oil, diesel, and lubricants remained trapped inside tanks that had been distorted by the grounding. Specialist teams carefully extracted the fuel through heated pumping systems, significantly reducing the environmental risk before the main salvage operation could begin. As preparations continued, enormous steel sponsons were fabricated and transported to Giglio. These hollow structures would eventually be attached to both sides of the ship. During the rotation, they would act as counterweights, and later they would provide the buoyancy needed to refloat the vessel. Their installation required powerful floating cranes, specialist divers, and months of meticulous work. More than a year after the disaster, the site had become one of the largest marine engineering projects ever assembled. Hundreds of specialists from dozens of countries worked around the clock, supported by floating construction platforms, tugboats, barges, and advanced monitoring systems. Everything now depended on a single operation. If the parbuckling failed, years of preparation could be lost in a matter of minutes. On the 16th of September, 2013, after more than 20 months of planning and preparation, the parbuckling operation finally began. Engineers had chosen a period of favorable weather, but success still depended on thousands of individual components performing exactly as designed. Around the world, millions watched the live broadcast as one of the most ambitious salvage operations in history got underway. Powerful hydraulic strand jacks slowly tightened their steel cables, applying immense but carefully controlled force to the wreck. The movement was almost imperceptible at first. Measuring instruments confirmed that the ship was rotating by only a few degrees each hour. Engineers monitored stresses throughout the hull continuously, ready to pause the operation if any unexpected movement threatened the vessel's structural integrity. As the rotation continued, Costa Concordia gradually lifted away from the rocks that had held her since the night of the disaster. For the first time, parts of the damaged port side became visible. The enormous gash ripped through the hull by the submerged reef revealed the devastating force of the original collision and confirmed why flooding had spread so rapidly throughout the lower compartments. Hour after hour, the ship continued its slow, deliberate journey towards an upright position. The underwater support platforms now accepted more of the vessel's weight exactly as engineers had intended. Every stage followed a carefully rehearsed sequence, with survey teams, structural specialists, and hydraulic operators coordinating each adjustment to keep the rotation stable. After almost 19 hours of continuous work, Costa Concordia finally settled upright onto the prepared platforms. Applause erupted from the control center and support vessels surrounding Giglio. Although the ship remained badly damaged and could not yet float, the most dangerous phase of the salvage had been completed without loss of life. It was an engineering achievement widely regarded as a milestone in modern marine salvage. The operation, however, was only halfway complete. Engineers immediately began preparing the next stage by attaching additional sponsons to the opposite side of the hull. Once these giant buoyancy tanks were sealed and gradually filled with air, they would provide the lifting force needed to refloat the wreck. The ship had been turned upright, but many months of complex work still remained before Costa Concordia could finally leave Giglio. Following the successful parbuckling, work entered a new and equally demanding phase. Engineers continued attaching additional sponsons along both sides of the hull. These giant steel tanks would eventually provide enough buoyancy to lift the ship clear of its underwater platforms. Every compartment had to be inspected, reinforced where necessary, and prepared to withstand the stresses of refloating. Throughout the following months, compressed air was gradually introduced into selected sponsons, while seawater was pumped out in carefully controlled stages. The process increased the vessel's buoyancy little by little, allowing engineers to monitor how the damaged hull responded. Raising the ship too quickly risked twisting or fracturing the weakened structure, so progress remained deliberately slow. By July 2014, Costa Concordia began floating under her own buoyancy for the first time since the disaster. Although still heavily damaged, the ship had been successfully lifted from the seabed. Salvage crews carried out extensive inspections beneath the hull, confirming that the support platforms could be removed and that preparations for departure could finally begin. The next challenge was transporting the enormous wreck across the Mediterranean. Temporary systems remained in place to monitor stability, control flooding, and maintain structural integrity throughout the voyage. Tug operators, marine engineers, and maritime authorities coordinated every aspect of the journey, recognizing that even in her refloated state, Costa Concordia remained a fragile vessel. On the 23rd of July, 2014, surrounded by a fleet of escort vessels, the wreck slowly departed Giglio. Residents who had lived beside the stranded liner for more than 2 years watched as the ship was carefully towed away from the island. For many, it marked the end of a difficult chapter that had profoundly affected their community. The convoy traveled cautiously towards Genoa at only a few knots, with salvage teams continuously inspecting the hull and monitoring weather conditions. The route had been planned in meticulous detail to minimize risk to nearby coastlines and marine traffic. Every day of the voyage demonstrated the extraordinary level of planning that had gone into the recovery. When Costa Concordia finally entered the port of Genoa, the unprecedented salvage operation had achieved its primary objective. Against enormous technical, environmental, and logistical challenges, the wreck had been stabilized, rotated upright, refloated, and transported intact. Yet one final stage remained. The ship that had once carried thousands of holidaymakers would now begin its final transformation into scrap steel. Once safely berthed in Genoa, Costa Concordia entered the final chapter of her remarkable story. The vessel that had once represented the height of modern cruising was now destined for dismantling. Before cutting could begin, engineers carried out detailed inspections to ensure the damaged hull remained stable. Hazardous materials, damaged equipment, and remaining pollutants were identified and removed under strict environmental controls. The dismantling process would take many months. Rather than demolishing the ship in a single operation, specialist teams worked deck by deck, carefully removing furniture, machinery, electrical systems, and kilometers of cabling. Valuable materials were separated for recycling, while hazardous substances were disposed of using tightly regulated procedures. The sheer scale of the vessel meant that every stage required careful planning and coordination. Thousands of tons of steel were eventually cut into manageable sections using heavy industrial equipment. Large cranes lifted each section from the hull before it was transported for recycling. Throughout the process, engineers monitored the ship's structural behavior, ensuring that removing one section did not compromise the stability of those remaining. Even in dismantling, Costa Concordia demanded the same level of precision that had characterized her recovery. Meanwhile, investigators and prosecutors completed years of inquiries into the disaster. Evidence from navigation systems, bridge recordings, survivor testimony, and technical experts was examined in detail. The findings concluded that a series of human decisions, rather than mechanical failure, had led to the collision, delayed evacuation, and tragic loss of life. The case became one of the most closely scrutinized maritime investigations of modern times. The disaster prompted significant changes across the cruise industry. Emergency musters were required before or immediately after departure. Bridge resource management received greater emphasis, and navigation procedures near coastlines were strengthened. Cruise operators and regulators also reviewed emergency communications, crew training, and evacuation planning to reduce the likelihood of similar failures occurring again. By the time the final sections of Costa Concordia disappeared into recycling facilities, almost nothing remained of the ship that had once sailed proudly through the Mediterranean. Yet the lessons learned from her loss continued to influence ship design, emergency preparedness, and operational decision-making. Although the vessel itself had vanished, its impact on maritime safety would endure for many years to come. The Costa Concordia disaster became far more than the story of a shipwreck. It exposed how a sequence of seemingly manageable decisions could combine to produce catastrophic consequences. Calm seas, favorable weather, and a modern vessel were not enough to prevent tragedy when judgment, communication, and emergency management failed at critical moments. The disaster demonstrated that technology can enhance safety, but it can never replace disciplined leadership and sound decision-making. The response that followed revealed another side of the story. Thousands of people contributed to the rescue, investigation, and recovery. Residents of Giglio opened their homes to strangers, emergency responders searched tirelessly for survivors, and engineers from around the world worked together to solve problems that had never before been encountered. Their combined efforts transformed a disaster into one of the greatest examples of international maritime cooperation. The salvage of Costa Concordia remains a landmark achievement in engineering. Stabilizing, rotating, refloating and removing a cruise ship of more than 114,000 gross tons had never previously been accomplished. Every stage demanded innovation, patience, and extraordinary precision, proving that even the most complex technical challenges can be overcome through careful planning and international collaboration. For the families of the 32 people who lost their lives, however, no engineering success could erase the human cost. Behind every statistic was an individual with dreams, ambitions, and loved ones waiting for them to return home. Their stories remain the true legacy of the disaster, reminding us that maritime safety is measured not by ships or regulations, but by the lives those measures are designed to protect. Today, passengers boarding cruise ships around the world encounter safety procedures shaped in part by the lessons of Costa Concordia. Mandatory safety drills, improved bridge resource management, stronger operational oversight, and enhanced emergency planning all reflect knowledge gained through painful experience. The industry continues to evolve because the consequences of forgetting those lessons are simply too great. The wreck has disappeared, the steel has been recycled, and Giglio's coastline has returned to its natural beauty. Yet the image of Costa Concordia lying on her side remains one of the defining photographs of modern maritime history. It is remembered as both a tragedy and an extraordinary feat of engineering recovery. Above all, it stands as a lasting reminder that at sea, professionalism, preparation, and respect for the limits of human judgment remain the strongest safeguards against disaster.